Hello, welcome back to this video. This is 11-6, and we are talking triangle problems in context. We're going to go ahead and dive right into it. If you need a little bit more background information, you can check the previous video. We did a couple of examples and talked about just our general principles we're applying here. All right, so again, we want to go ahead and solve a triangle problem in context. So here is the context. It says a pilot is flying from Houston to Oklahoma City. Now, the direct route is 396 miles. However, makes sense, right? Going to Oklahoma City, there is a thunderstorm. So in order to avoid a thunderstorm, the pilot flies 28 degrees off of the direct route for a distance of 175 miles. He then makes a turn and flies straight on to Oklahoma City. Excuse me. To the nearest mile, how much longer, so here's the question, and this is a good thing to always know too, how much longer than the direct route was the route taken by the pilot? So let's go ahead, let's draw an image, okay? So let's put Houston down here, okay? I'll call this H, and then we have Oklahoma City, which is up here, up further north, okay? And that direct route, they say, is 396 miles, okay? But what he has to do is the pilot has to fly 28 degrees off course. So there's 28 degrees, and he flies that direction for a total of 175 miles before making a turn. And in order to be a triangle problem, it has to be a very sharp turn. I feel bad for the people on that plane. And there's the given information. Okay, so they want to know how much longer. So what we're going to do, we need to know, okay, 175 miles plus this given route here, which we'll call, I'll call it little h, right? So I have to add those together and then take those away from 396. Okay, so I have to find h. Now, it's not a right triangle. Okay, I don't know that. I mean, it could be, but doubtful. And I don't have a matching pair in sides. So what we're going to have to do is we're going to have to go ahead and find h by using the law of cosines. Okay, so find h. I'm going to have to use law of cosines. So remember, in order to find h squared is equal to the other side squared, so 396 plus 175 squared minus 2 times those two sides. Okay, times cosine of that side, or that angle, which is 28. Okay? All right, so if I want to go ahead and find h is equal to the square root of all that amount. 396 squared plus 175 squared minus 2 times 396 times 175 times cosine of 28. Okay, we calculate all of that and we get h is approximately 255 miles. Okay, so if I want to figure out how much longer, so now I'm going to find the difference. Okay, so the difference is going to be 175, right, plus 255. Okay, that's how much was flown approximately. That's 430 miles. Okay, and then if I want to figure out the difference, I can take 430 and I can subtract the direct flight amount, which gives us approximately 34 miles. Okay, so what we can conclude is the route taken by the pilot was about 34 miles longer. Okay, and there you have it. All right. The next problem that we're going to look at, okay, says Lucas is staying at a cabin and plans to go on a hike in the morning to a cave and then from there to a waterfall. Okay, so Lucas is at a cabin and he plans to go on a hike in the morning to a cave and then a waterfall. He knows, okay, so he knows that the hike from the cabin to the cave is 3 miles, and from his cabin to the waterfall is 4 miles, but what he doesn't know is the distance from the cave to the waterfall. So it says from the cabin, okay, so from the cabin, an angle of 71.7 degrees is formed between the cave and the waterfall. Okay, and then they're going to give us another rate here. They say if Lucas hikes at an average of 2.5 miles per hour, estimate to the nearest tenth of an hour, how long will it take for him to reach the waterfall? Okay, so lots of information. Let's go ahead and draw a picture of all of this. Okay, so I'm going to say here's the cabin. Okay, and then here is the cave. Okay, and then up here we'll put the waterfall. Beautiful image. Okay. All right, so let's plug in the information that we're given. So it says the cabin to the cave is 3 miles. Okay, so I know that's 3. The cabin to the waterfall is 4 miles. Okay. He doesn't know the distance from the cave to the waterfall. And then it says from the cabin, an angle of 71.7 is formed with the cave and the waterfall. So this is 71.7 degrees. Okay. All right. They want to know how long will it take for him to reach the waterfall. Okay. So it's important to note kind of his order, right? So Lucas is staying at the cabin. He goes on a hike to the cave and then from there to the waterfall. So what I really need to know his distance. Okay, so his total distance is going to be equal to the 3 miles, right? Plus the distance of this side, which I'll call x, right? 3 plus x. And then we're going to have to go ahead and take into account his average speed. Okay, so let's go ahead and find x. So I want you to take a second. Please pause the video. What formula are we going to use? What function? Okay, so hopefully you thought about that. Looking at this, it's not a right triangle. I can't use SOHCAHTOA. Can't use Pythagorean theorem. I don't have a relationship between a side and an angle, so law of sines is out, so it is law of cosines, right? So I have x squared is equal to 3 squared plus 4 squared minus 2 times 3 times 4 times cosine of 71.7. And I hope you figured out a quick trick. I can just take the square root of both sides, and there is my law of cosines, okay? And this gives us approximately 4.179 miles, okay? So his total distance, right, is approximately 7.179 miles, okay? So remember that time is equal to distance divided by rate. So I have 7.179 divided by 2.5 miles per hour, right? This is miles. This is miles per hour. And what we get is approximately 2.9 hours. All right. That was easy. So it will take Lucas about 2.9 hours to reach the waterfall. Okay. All right, next example. Here we are told that a 5.5 foot tall person standing 50 feet from the base of a tree, okay, sights an angle of elevation from his line of sight to the top of the tree. Okay, so from his line of sight to the top of the tree at 71.5 degrees. It says estimate the height of the tree in feet and inches. Okay, so let's go ahead and draw a picture. We have a tree here. Don't make fun of my drawings. They're beautiful. Okay, so there's a tree. And then we have a 5.5 foot person. Okay, there they are. And they're 5.5 feet. Okay, standing 50 feet from the base of the tree. Okay, sights an angle of elevation from his line of sight to the top of the tree. So here's the top of the tree. Here's his line of sight. Okay, at 71.5. Now, it looks a little low to be 71.5. I think my tree needs to be taller, but it will do. Okay, so what we want to know is we want to know how tall the tree is. Here's our desired information, this whole thing. Okay, well, I do know this distance, right? Isn't this distance 5.5 feet? Okay, what I'm missing is this information here, x. Okay, so I have an angle, right, involving a side that is opposite, and I have the side that is adjacent, and it happens to be a right triangle, right? Here's our right angle. So can't I go ahead and use tangent? Sure can. Okay, so tangent of 71.5 is equal to x over 50. So thus x is equal to 50 tan 71.5, okay, which gives us approximately 149.434 feet. Okay, all right. So what I want to do is I want to find the total height of the tree. Okay, so I'm going to go ahead. I'm going to take this value, 149.434, and I'm going to add 5.5 to it to give us approximately 154.934 feet. All right, so that's the height of the tree. I just added it, right, to how tall that person was. Now, what I do want, though, is they want feet and inches. I mean, I do know that the tree, so I can say the tree is for sure 154 feet tall. Okay, but what I need to do is I need to calculate, right, how many inches is 0.934. Okay, so this is feet. So I want inches. So I'll go ahead and convert 12 inches in a foot. And this gives us approximately 11 inches. So 154 feet and 11 inches. All right, there you have it. That's the height of the tree. See, so these problems aren't too bad. You do need a picture, and then you need to know like what can you apply. I have a practice problem here for you, and it is a pretty good practice problem. Please pause the video. I want you to try this. Make sure you draw a picture. If you need to take a peek, I'll kind of reveal part A and then part B later on. Okay. All right. So hopefully you pause the video. Here is part A. Here's the solution. So there's an image. And then make sure, again, you placed your degrees in the correct location. Okay, so the satellite is about 82.8 miles from Columbus Tower, all right, using the law of sines. Straightforward. Okay, and then altitude, part B. What is the satellite's altitude? Remember, that's height. So straight up and down. Hint, hint. Okay, and then here is part B. So hopefully you drew an altitude. Okay, you can use law of sines, or, I mean, did you think about using SOHCAHTOA, right? I mean, I have all the given information now. Okay. All right. So that will do it for me for this video. That is triangles in context. I hope you enjoyed it. I hope you learned something. Okay. Work on your reading comprehension and your translation from English to math. Catch you next time. Peace.